In this section, we're going to go over section 11.4, and the topic is fundamentals of probabilities. So probability, it can take a range of values from 0 to 1, and in terms of a percentage, from 0% to 100%. At 0% or 0, the event is classified as impossible. Between 0 and 1/2 or 50%, that's what you may have heard people saying that there is a 50-50 chance. And between 50 and 100%, things can be likely, but if they are 1 or 100%, they can be certain. So those are the possible values for probabilities. Probabilities are assigned values, as I mentioned, from 0 to 1. The closer the probability of a given event is to 1, the more likely it is that the event will occur. The closer the probability of a given event is to 0, the less likely that the event will occur. So in theoretical probability, an experiment is an occurrence for which the outcome is uncertain. So in an experiment, you will create a sample space, and that is the set of all possible outcomes of an experiment. And we use a capital letter S to denote the sample space. Events are, we use the capital letter E, and the event, it is a subset of the sample space. So the sum of the theoretical probabilities of all possible outcomes is equal to 1. So we're going to be computing the theoretical probability, and I call that one also the book theory probability. If an event, capital E, has n of E, so the number of events are equally likely to occur, outcomes, and a sample space S is called n of S, is the number of outcomes in the set or the number of outcomes in the event. The theoretical probability of the event will be denoted as P of E, that means the probability of the event, is equal to the number of outcomes in the event divided by the total number of possible outcomes, and that is in the sample space. So now we're going to go over example 1. A die is rolled once. Find the probability of rolling the following. So first of all, when it doesn't state how many sides does a die have, it is understood that it is the standard 6-sided die. So the possible outcomes, or we can say the sample space, are the numbers between 1 and 6. Find the probability of rolling. In this case, what is the total number of possible outcomes? So first they're asking you for what is the total number of possible outcomes. So in here we have, you can get a 1, a 2, a 3, a 4, a 5, or a 6. So the total number of possible outcomes is 6. So when we ask you for what is find the probability of rolling a 3, that means the probability of the event. So the number of 3s that you have in the sample space, there is only 1 out of the 6 numbers that is a 3. So this is a 1. So in order to find the probability, it's going to be the number of events, in this case the number of 3s that you have, that is 1, divided by the number the number of outcomes in the sample space, that is 6. And that's how you get the probability of this particular event. In part B, you're asked to find the probability of even numbers. So out of the sample space, that is 1, 2, 3, 4, 5, and 6, the even numbers are 2, 4, and 6. So the event is a subset of the sample space. So the number of outcomes that are even, the number of numbers that are even, is equal to 2, 4, and 6. That's 3 numbers that are even. And out of the number of possible outcomes that is in the sample space, that is 6. So 3 out of 6, that you need to simplify this to the fraction that is 1/2. Again, when you're asked to find a probability, the type of answers that you will get are either a simplified fraction, a decimal, or a percent. So those are the different forms. But you will always start with a fraction. So now we're going to work on example number 2. On example number 2, we are working with a 14-sided die is rolled. So here we are telling you how many sides it has. So that means that you can get a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10, 11, 12, 13, 14. So that is your complete, those are all the possibilities that you have here. So this is the number in the sample space is 14. That will be your denominator. So what is the number of outcomes for the event? You are being asked to find the probability of rolling a number less than 8. So if you are looking for a number that is less than 8, that is 1, 2, 3, 4, 5, 6, 7. So you stop at the 7 because it says less than 8. So there are the number of outcomes in the event is 7. So the probability is going to be the number of outcomes in the event divided by the number of in the sample space of all the possible outcomes. It is 7/14. That simplifies to 1/2. So in part B, you're asked to find an odd number. And again, we're working with a 14-sided die. So odd numbers are 1, 3, 5, 7, 9, 11, 13, and that's it, because we end in 14. So 1, 3, 5, 7, 9, 11, 13. So those are the odd numbers. So the number of outcomes in the event is 1, 2, 3, 4, 5, 6, 7. So you have 7 outcomes in the event of the number of odd numbers. And so you will have 7 divided by, and the entire sample space is 14. So again, this is simplifies to the fraction 1/2. And here it's asking you for a number less than 15. So all of the numbers in the 14-sided die are less than 14. So they're going to be 14, and the possible outcomes in the event or the sample space is 14. So 14 divided by itself equals 1. Next, we have a number greater than 20. If it is a 14-sided die, none of the numbers are greater than 20. So there's 0 outcomes in that event. So this is going to be 0 divided by 14, that equals 0. So we're going to continue the section in the next video.